Well, we spent all of last chapter adding and subtracting and multiplying polynomials. Uh, we've been doing a lot of factoring as well, and factoring is dividing polynomials, and we're going to do that some more during this lesson, section 7 of chapter 11, rational equations and functions. So here we go. We're being asked to divide this trinomial, quadratic trinomial, 9x squared plus 12x minus 18, by this linear monomial, 3x. Okay, well, I mean, we can look at that like this. When we say we're dividing by 3x, we're dividing this entire trinomial by 3x. Now that can also be looked at a little bit differently. That's like three different fractions. 9x squared divided by 3x, 12x divided by 3x, and negative 18 divided by 3x. Now, at this point, all we have to do is simplify each of these three fractions, and given what we know about fractions and what we know about exponent rules, that shouldn't be very difficult for us. 9 divided by 3 is 3. X squared divided by x is x. 12 divided by 3 is 4. X divided by x is 1. And 18 divided by 3 is 6. There's no x on top here, though, so we have to leave that x in the denominator. This would be our final answer. Maybe we haven't seen something like that where the variable appears in the denominator before, and maybe we wouldn't consider this standard form, but we'll go ahead and leave our answer like that for right now. Use long division to divide 453 by 18. We're doing this because we want to draw a comparison with division of whole numbers like this to division of polynomials. So let's take a look at it. So we'll take 453 and we're going to divide that by 18. So the first thing we have to think and ask ourselves is, okay, how many times does 18 go into 4? It doesn't at all. So we'll go to the next number, 45. 18 goes into 45 twice, and 2 times 18 is 36. At this point, you probably remember that you're supposed to subtract the 36 from the 45. You get 9 left over. It's actually 90, but we'll bring down the 3 and make it 93. So then we ask ourselves again, how many times does 18 go into 93? It goes in there 5 full times. 5 times 18 is 90, which leaves 3 left over, and 3 is our remainder. Okay, now when I say 3 is the remainder, I mean 3/18. That's another way of saying the remainder. 25 and 3/18. That's a fraction that can be simplified, 25 and 1/6. 453 divided by 18 is 25 and 1/6. Okay, so we're going to do that same thing when we're dividing polynomials here. We're going to use long division. Polynomial long division is what your book calls it. I've heard it called synthetic division in the past. So at any rate, we'll set it up the same way. Here's our first number, our polynomial, and we're going to divide by the second polynomial, x plus 3. Okay. Now what we're concentrating on here is the lead term, x. How many times does x go into 3x squared? Or perhaps you want to ask yourself this a little bit differently. X times what is 3x squared? X times 3x is 3x squared. Okay, so x times 3x is 3x squared. Or 3x squared divided by x is 3x. So we'll go at 3x times x is 3x squared, and we're going to continue that. 3x times 3 is 9x. So we just take this, 3x, and we multiply it by the x plus 3. 3x squared plus 9x. Now we subtract these polynomials. Careful here. You should get negative 2x. 7 minus 9 is negative 2. Bring down the negative 12. And then we're going to go through the same process again. X times what is negative 2x? X times negative 2 is negative 2x. Then we'll take the negative 2 and we'll multiply it by x plus 3. Negative 2x minus 6. Negative 2 times x is negative 2x. Negative 2 times 3 is negative 6. And again, we'll subtract. Be careful. Negative 12 minus negative 6 is like negative 12 plus 6, which is negative 6. That's our remainder, negative 6. We can't turn x. We can't multiply x by anything to get negative 6. So we'll put it up there in the form of a fraction, negative 6 over x plus 3. Just like in the last example, we did 3 was our remainder, and we put it over 18. So we went 3 over 18. It's the same exact process. All right, so why don't you use the last couple examples as a guide and try this one on your own. And when you're ready, press play and you'll see my answer. Okay, so let's set this up. We're dividing both by negative 2p. When it's a monomial that we're dividing by, this might be your easiest route. You can use long division though. So 4 divided by negative 2 is negative 2. P squared divided by p is p. You got two negatives, which makes a positive, and 10 divided by 2 is 5. The p's cancel out here. And that's our answer. 4p squared minus 10p divided by negative 2p is negative 2p plus 5. And if you multiply this answer by what you divided by, you should get 4p squared minus 10p. Okay, try this one. You're going to need to use long division. Press pause, and when you're ready to see my solution, press play. All right, so we're going to go x squared minus 3x plus 5, and we're going to divide it by x plus 2. So we ask ourselves, x times what is x squared? X times x is x squared, and x times 2 is 2x. Then we subtract. This is where a lot of people might make a mistake here, but negative 3 minus 2 is negative 5. Bring down the 5. X times what is negative 5x? X times negative 5 is negative 5x. And negative 5 times 2 is negative 10. We subtract. It's actually 5 plus 10, or 5 minus negative 10. And that's our remainder. 15, we'll put it in fraction form, 15 over x plus 2. So x squared minus 3x plus 5 divided by x plus 2 is x minus 5 plus 15 over x plus 2. All right, this one's just slightly different. And we'll hopefully recognize this when it becomes a problem. But we need to use 0 as a placeholder here. We're going to need that 0n. So we'll just add that in for our dividend. Our divisor is n plus 1. Okay, so n times what is 5n squared? 5n. 5n times n is 5n squared, and 5n times 1 is 5n. Hopefully now you can see why we needed that 0n. We need the like terms here to be in a row. It's possible you might have to add a 0n or a 0n squared, something to hold a place in your divisor as well. Okay, so let's subtract. 0 minus 5 is negative 5, or negative 5n. Bring down the 2. N times what is negative 5n? Negative 5. Negative 5 times n is negative 5n. Negative 5 times 1 is negative 5. We'll subtract, careful. 2 minus negative 5 is like 2 plus 5. That's 7. So there's your remainder. 7 over n plus 1. All right, This one is also just got a slight little degree of difficulty because we need to take this polynomial and put it into standard form. So instead of x minus 12 plus 3x squared, let's make it 3x squared plus x minus 12. Always put it in standard form, and when we're dividing, we always need placeholders as well. We want to see the x squared and the x and the constant. So we're going to divide that by 3x plus 1. X times 3x is 3x squared, and x times 1 is x. Now on this one, everything cancels out. When you subtract, that's 0, and on this one, you subtract, that's 0. Bring down the negative 12. How do we turn 3x into negative 12? We can't. So that's our remainder, excuse me. Negative 12 over 3x plus 1. All right, so give this one a try using what we just learned in examples 4 and 5. Press pause, and when you're ready to see my solution, press play. All right, not only do we need to put this in standard form, we also need to add a placeholder here for the x term. Dividing by x minus 2. X times what is negative x squared? Negative x times x is negative x squared. And negative x times negative 2 is positive 2x. When you subtract, you'll get negative 2x. Bring down the 1 and ask yourself, x times what is negative 2x? X times negative 2 is negative 2x. And negative 2 times negative 2 is positive 4. When you subtract, you get negative 3 as your remainder. Put that in fraction form. All right, so hopefully you see the pattern. Hopefully you see how this is like long division that you learned a long time ago. If you need to rewatch any of the video, please do. The section starts on page 684 of your textbook. I highly recommend that you read it. Come in tomorrow with your completed note sheet and your questions, and we'll give it a try in class. Have a great night.